Recife is a city of 1.5 million, cut by the Beberibe and Capibaribe rivers, which meet and flow into the Atlantic Ocean. Currently, only 30% of Recife's sewage is treated, contributing to the proliferation of diseases such as Zika, dengue, and chikungunya, as well as exacerbating the problems of flooding and soil and groundwater contamination. The city contains 66 ZES, special zones of social interest, where basic sanitation problems are even more evident. In this study, 3 ZES were visited and analyzed in order to map the flow of wastewater and the disposal of solid waste, as well as to evaluate open areas for biodigester installation. A biodigester is a sealed chamber capable of fermenting organic material through the use of methanogenic bacteria without the presence of oxygen. From this decomposition, biogas and biofertilizers are produced, and wastewater is rendered more suitable to be returned to the environment. To map the ZES and their proximity to water bodies, CAD and ESIG, Geographic Information of Recife software, were used. The Caranguejo Tabaiares ZES is surrounded by environmentally protected areas. Approximately 6,500 people live in the community and send 60% of their sewage through the ABC Canal that empties into the Capibaribe River, one of the city's most important. The Borborema ZES sends 100% of its sewage into the Jordan Canal that flows into the Pina Basin. Its 12,000 residents produce 1,200 cubic meters of sewage per day and 468,660 cubic meters per year. In the Vila Arraes ZES, open sewers flow through the community, contaminating the Capibaribe River. Irregular disposal of sewage in a vacant lot surrounded by houses exposes the population permanently to the risk of contamination. The urban biodigester proposal was created based on relevant laws, technical standards, product manuals, and the volume of wastewater produced by a family of 5. The proposed unfamiliar urban biodigester guidelines took into account local laws, water supply, sewer and gas networks, and the presence of wells and water bodies. The proposed biodigester uses low-cost, easily available materials, such as a 5,000-liter fiberglass water cistern, PVC canvas, 100mm PVC pipes, a 4-inch spin connector for the biogas output, and a gas filter and meter, producing a device easy to install and maintain by the community's residents. The urban biodigester has been designed to handle up to 1 kilogram per person per day of total organic waste, plus 0.1 kilogram per person per day of feces and urine. It is estimated that the proposed biodigester will produce about 20 liters of liquid petroleum gas and 20 liters of biofertilizers per month, that if treated can be sold to agriculture. In summary, the proposed biodigesters aim to improve the output water quality, reduce contamination in lakes and rivers, and ameliorate the effects of flooding and the spread of disease.